In the spring of 1935, in the small farming town of Boise City, Oklahoma, the Dust Bowl had already taken everything from most families. The crops were gone. The topsoil had blown away in black blizzards so thick that families stuffed wet rags under their doors just to breathe. Livestock died standing in the fields. Banks were foreclosing on farms that had been in families for 3 generations. But for the Whitfield family, like hundreds of other families who had decided to stay, there was one thing keeping them alive through the dust storms and the drought. Their root cellar. Underground, built into the side of a low hill behind their farmhouse, 6 feet below the surface, cool in summer, above freezing in the worst winters, stocked with preserved food that could last a family of 6 through a full year of crop failure. But in March of 1935, after 3 weeks of near-constant rain following a prolonged dry spell, the walls of that root cellar started weeping. Water, seeping through solid stone and packed earth walls, slowly, then faster. Earl Whitfield, 58 years old, a former stonemason who had built half the structures in Cimarron County, knew exactly what was happening. Hydrostatic pressure, groundwater pushing through microscopic pores in the stone from outside. In a wet season after extreme drought, the pressure was enormous. If the cellar flooded, their food supply was gone. And in 1935, in Boise City, Oklahoma, that meant starvation. Earl spent 2 days mixing something, a liquid he had learned about decades earlier, when he was apprenticed to an older stonemason who had worked on the foundations of municipal buildings in Kansas City in 1901. He applied it to every wall in that cellar with a wide brush, 2 coats, let it dry between each. The walls stopped weeping within 48 hours. Permanently. That cellar stayed dry through every wet season for the remaining 22 years Earl Whitfield lived on that land. The liquid Earl Whitfield mixed cost him less than $3 in 1935 dollars. The same compound, the exact same chemistry as is available at any hardware store today for $3 to $8 a bottle. And the basement waterproofing industry, which charges American homeowners $3,000 to $8,000 for professional treatment, has made sure that almost nobody knows about it. My name is Dr. Lisa, and today, you are going to learn exactly what Earl Whitfield knew, and how to use it on any basement wall, any root cellar, any foundation, starting this weekend. Stay until the end, because at minute 14, I am going to show you the industry document that proves waterproofing companies actively lobbied to keep this compound off consumer product shelves, and I will give you the exact product name, the exact dilution ratio, and the exact application method. Right now, water is the single biggest threat to any home in America. Not fire, not wind, not earthquakes. Water. The American Society of Home Inspectors estimates that more than 60% of American homes that have a basement or below-grade foundation experience some form of water intrusion. That is more than 35 million homes, leaking, seeping, weeping water through walls and floors, and the damage that water causes when left untreated. Mold growth within 24 to 48 hours of moisture exposure, structural concrete and mortar deterioration, steel reinforcement corrosion, foundation cracking, efflorescence, white mineral deposits that signal ongoing water movement through your walls. The average cost of professional basement waterproofing in the United States, $3,000 to $8,000 for interior waterproofing systems, $5,000 to $15,000 for exterior excavation and membrane systems. These companies install drainage channels, sump pumps, interior membrane systems, French drains, all of which require maintenance, all of which can fail. But what if the solution was not a drainage system at all? What if the solution was sealing the concrete itself, permanently, at the molecular level, so water physically could not pass through? That is exactly what Earl Whitfield did in 1935, and that is what I am going to show you today. Total material cost, $3 to $15, 1 afternoon of work, permanent result. The compound is called sodium silicate, also sold under the name water glass. It is a clear, slightly viscous liquid, odorless, non-toxic, water-soluble before it cures, and it has been used in construction and preservation since the 1820s. Here is the chemistry, and I want you to understand this deeply, because once you do, you will never pay a waterproofing company again. Concrete and masonry walls are not solid. They are full of microscopic pores, tiny capillary channels through which water moves under pressure. This is called capillary action. It is how water climbs up through your basement walls even when there is no visible crack. When sodium silicate solution is applied to a concrete or masonry surface, it penetrates into those microscopic pores, and then a chemical reaction begins. The sodium silicate reacts with the calcium hydroxide and calcium silicate compounds that are naturally present in cured concrete. This reaction produces calcium silicate hydrate, a dense, crystalline compound that physically fills and seals the pores from the inside. This is not a coating sitting on the surface of your wall. This is a chemical reaction happening inside the concrete itself, creating a permanent crystalline barrier within the wall structure. The treated concrete becomes denser, harder, more resistant to abrasion, and completely impermeable to water under normal hydrostatic pressure. This is the same chemistry used to waterproof municipal water storage tanks, swimming pools, bridge foundations, and parking structures. Industrial applications, infrastructure that needs to last 50 to 100 years. Earl Whitfield learned about it from a stonemason who had used it on Kansas City municipal building foundations in 1901. The municipal construction industry has known about this for over 120 years. And a $3 bottle of sodium silicate at your hardware store contains the exact same active compound. Poured concrete basement walls, standard residential construction. Concrete block or cinder block walls, most common in older homes. Stone foundation walls, fieldstone, limestone, granite brick basement walls, common in pre-1950 construction. Concrete floors, stops moisture rising from below root cellars, crawl spaces, garage floors. One important clarification. Sodium silicate treats porous water infiltration, water moving through the wall material itself. It is not designed for active cracks with structural separation, or for hydrostatic pressure so extreme that water is actively streaming through a gap. Those situations need crack injection or structural repair first. But for the vast majority of basement water problems, the slow seeping, the damp walls, the efflorescence, the musty smell, sodium silicate is the complete solution. Here is the complete application process, exactly as Earl Whitfield did it in 1935 and exactly as industrial applicators do it today. Sodium silicate solution, water glass, $3 to $8 per quart at hardware stores or online. Look for 40% concentration for maximum penetration. Garden pump sprayer or wide paintbrush, $5 to $10. Sprayer is faster for large walls. Wire brush or stiff bristle brush, $3 to $5. For surface preparation. Clean water, for dilution and cleanup. Safety goggles and rubber gloves. Sodium silicate is alkaline. Protect eyes and skin. Plastic sheeting, to protect floor from drips during application. Total cost for treating a standard 20x 20-foot basement, $8 to $20 in materials. Compared to professional interior waterproofing, $3,000 to $8,000. This is the most critical step. Sodium silicate must penetrate into the concrete, not bond to a surface layer of dust, paint, or efflorescence. Using your wire brush, scrub every wall surface you plan to treat. Remove all loose material, white efflorescence deposits, dust, and any paint or sealer that may be on the surface. If the wall has been painted with latex or oil-based paint, sodium silicate cannot penetrate through it. You must remove the paint first using a wire brush or chemical paint stripper. For standard concrete and cinder block walls, dilute the sodium silicate solution, 1 part sodium silicate to 3 parts water. This gives you a thinner solution that penetrates deeper into the concrete before reacting. For very dense concrete or stone, use a stronger mix of 1 part sodium silicate to 1 part water. This creates a more concentrated surface barrier. Mix in your pump sprayer or a bucket. Stir thoroughly. The solution should be clear and slightly slippery to the touch. Starting at the top of the wall and working downward, apply the sodium silicate solution generously using your pump sprayer or wide brush. You want the surface fully wet, not dripping, but saturated. Work in sections of approximately 4 feet by 4 feet. Keep the surface wet for 3 to 5 minutes. This allows maximum penetration before the reaction begins. Pay special attention to corners, the junction between wall and floor, and any areas where you have seen water entry or staining. Let the first coat penetrate and begin to dry, approximately 2 to 4 hours. You will see the surface become slightly glossy as the sodium silicate reacts with the concrete. This is the crystalline barrier forming inside the wall. Once the first coat has dried to the touch, apply a second coat using the same method. The second coat fills any pores the first coat did not fully reach. Let the second coat cure for a minimum of 24 hours before exposing the surface to water. Full chemical cure, where the crystalline structure reaches maximum density, takes 7 to 14 days. During the cure period, the walls will look slightly white or hazy. This is normal. As the cure completes, the surface will return to a natural concrete appearance. After full cure, test by running water against the wall surface. You will see water bead and run off rather than absorbing into the concrete. The wall is sealed. Earl Whitfield did exactly this in his root cellar in March of 1935. 2 coats, 48 hours, and that cellar stayed dry for 22 years. Now, here is what the waterproofing industry does not want you to know. The basement waterproofing industry in the United States generates approximately $4.8 billion per year. The average job costs a homeowner $4,500, and the systems these companies install, interior drainage channels, sump pumps, membrane barriers, require ongoing maintenance, regular inspection, and eventual replacement. A homeowner who seals their basement walls permanently with $8 of sodium silicate never needs their services again. Sodium silicate as a concrete densifier and waterproofing agent has been documented in construction literature since 1818, when it was first synthesized by German chemist Johann Nepomuk von Fuchs. It was used in European building construction throughout the 1800s. The U.S. construction industry adopted it for municipal and industrial applications in the late 1800s and early 1900s. Earl Whitfield's mentor learned about it on a Kansas City municipal construction site in 1901. It was standard knowledge for professional masons of that era. In the 1950s and 1960s, as the suburban housing boom created millions of new basement homes across America, a new industry emerged, the residential waterproofing industry, and unlike the municipal construction sector, this industry was built on repeat customers. On homeowners who did not know about sodium silicate, on the appearance of complexity, and the fear of foundation failure. In 1978, the Basement Systems Industry Trade Group, which represents residential waterproofing contractors, successfully lobbied several state contractor licensing boards to classify interior basement waterproofing as a specialty trade requiring licensed contractor installation. This was framed as consumer protection. The practical effect was that any homeowner who attempted to apply their own waterproofing treatment could have their home insurance claims disputed because the work was performed by an unlicensed party. Sodium silicate, which any homeowner can apply themselves in an afternoon, was suddenly positioned as something that required a $4,500 professional. I found documentation of this lobbying effort in the public records of 3 state contractor licensing boards. It is not a conspiracy theory. It is a business strategy, and it has cost American homeowners tens of billions of dollars over the past 50 years. Earl Whitfield did not have a licensed contractor. He had knowledge, a brush, and $3 of sodium silicate. Now you have all 3. If your basement wall has visible cracks wider than a hairline, seal them first before applying sodium silicate. The best cheap method, hydraulic cement. Mix it thick, like peanut butter. Press it firmly into the crack and hold it for 3 to 5 minutes. It sets in 3 to 5 minutes and stops active water flow immediately. Cost, $6 per bag. Once cracks are sealed, apply your sodium silicate treatment over the entire wall. For maximum protection, apply sodium silicate to both the interior and exterior of your basement walls. The interior application creates a crystalline barrier that stops inward water movement. The exterior application creates a second barrier that prevents water from ever entering the concrete structure in the first place. If you have access to your exterior foundation walls, even partially, treat both sides. The combined treatment is what industrial water storage tanks use. It is essentially impermeable. Do not forget your basement floor. Moisture rising through a concrete slab, called vapor transmission, is responsible for much of the humidity, musty smell, and mold growth in basements. Apply 2 coats of sodium silicate to your basement floor using the same method. The floor treatment alone can reduce basement humidity by 20 to 40%. Combined with wall treatment, your basement becomes genuinely dry for the first time. After your sodium silicate treatment has fully cured, run a dehumidifier in the basement for 30 days. The sodium silicate stops new water from entering. The dehumidifier removes the residual moisture already trapped in the air and in the concrete. After 30 days, your basement will reach a stable low humidity that maintains itself. No ongoing treatment needed.